So now let's look at the more exotic index types, even though I would say that a bitmap is probably exotic and possibly even a function-based index is exotic as well. But bitmaps and function-based indexes are actually used quite frequently, not nearly as much as B-trees. One of the problems with bitmaps and function-based indexes is that they're often inappropriately used, so you have to be careful how and where you use them. An indexed organized table. As you can see from the diagram, all it does is it takes the table and the index concept and joins them together. So as opposed to just having a single column in a tree structure, it takes every single column in the row and adds that to the index. So you end up with not too many branch nodes, but lots and lots of leaf nodes, because the leaves get filled very quickly, because you're not just putting a single column value into each leaf node for each row ID, you're sticking the entire row in there. So you want to be careful using IoTs. They can be really efficient if you read everything in the order of the IoT. They can be efficient for doing DML activity as long as you stick to that IoT structure. You stick to the index structure. So if you index based on a single column, always read and write that table with a single column. It is possible to work with the table without using the index or not sticking to the structure of the index, but it's very likely that it's going to be extremely inefficient and difficult to use. A cluster, as I said, it takes a certain chunk of information and forms, if you like, a separate object out of it. Typically, clusters are used to join together chunks of data that are commonly used from multiple tables, and then you execute joins against the cluster. In other words, you just go and read the cluster. In Oracle, you technically read the cluster itself, which means as opposed to telling the database to, or your SQL commands to read the table, you tell it to read the cluster object. All it's doing is it's taking the act data on the left, starting with Paul McCartney and the venues, and it's removing all the other columns from those two tables, and it's creating a new object that contains just those two columns. Obviously, if you want to read just those two columns, you read the cluster. If you want to read other data, there's no point in reading the cluster, because you're going to end up joining the cluster back to the original tables, which is completely pointless. There is another type of object that creates copies of data called a materialized view, which is a special type of view. We will get to it later on. It's a little bit like a cluster and kind of really the successor to clusters. Clusters are very out of date. I have not seen them used in Oracle for years, other than in legacy applications. In fact, in a custom environment, I don't think I've even created one in 10 years. That's how far out of date they are. But obviously they're still there, because Oracle needs to cater to backward compatibility, because a lot of applications could already have been written using clusters, and you can't expect, or Oracle can't expect, their clients to rewrite and rebuild all their applications and databases. And then there's people that build custom off-the-shelf apps and sell them to other companies. Just you can't remove things. It's too complicated, too messy. Here's a bitmap join index. All this does is basically creates two bitmaps joined together that allows you to read a joined chunk of data using a bitmap that's stuck together. It's like a pre-join query. Very simple, but very unusual. I have tried to use it once. It didn't really have much success in terms of speed. I was working with a data warehouse quite a long time ago. They may be better now, but I doubt it. Domain indexes are used to store context type structured data, such as large documents, XML, spatial or geometric data, multimedia. They're used to basically look into large documents to build indexes within those large documents, such as in libraries